This is Dr. Eti. Now today we are going to discuss about by the principle of finite mathematical induction theorem. The given statement here a plus d, a plus 2d plus so on plus n terms equals to n by 2 into 2a plus n minus 1 into d. Okay, our statement how to solve the solution by the principle of finite mathematical induction. The given statement is true for n equals to 1 and n equals to k. Next, that prove that n equals to k plus 1. The given statement means here a plus d plus a plus 2d plus so on plus n terms equals to n by 2 into 2a plus n minus 1 into d. Okay, here the n terms of the given expression a plus d, a plus 2d plus so on equals to a plus n minus 1 into d. Okay, in place of n, the given statement write a plus n minus 1 into d, a plus d plus a plus 2d plus so on plus a plus n minus 1 into d equals to n by 2 into 2a plus n minus 1 into d. Assuming that this is the equation number 1 and the given statement as usual here assuming that s of n. Okay, the given statement first of all prove that let n equals to 1 both LHS and RHS. LHS means here in place of n substitute 1, this is 0, will get a. Next that RHS substitute RHS n equals to 1, that is 1 by 2 into 2a, 1 by 2 into 2a, 1 minus 1 into d, 0. Therefore 2 gets cancels a. Therefore LHS equals to a and RHS equals to a. Therefore the given statement is true for n equals to 1. It's true for n equals to 1. The given statement is true for n equals to k. Okay, here substitute in place of n k by equation 1, that is a plus d plus a plus 2d plus so on plus a plus k minus 1 into d equals to k by 2 into 2a plus k minus 1 into d. 2a plus k minus 1 into d. This is equation number 2. Next of all, here the given statement. Now we are going to prove that n equals to k plus 1. Okay, first of all we have to prove that n equals to k plus 1. First of all, the n terms substitute in place of n k plus 1, that is a plus d plus a plus 2d plus so on equals to a plus k plus 1. In place of n substitute k plus 1 minus 1 minus 1 into d. Minus 1 plus 1 gets cancelled. This is a plus kd. Now, by equation 1, in place of this is assuming that equation 2, by equation 2, already assume here equation 2, substitute in place of nk. In this equation, adding LHS and RHS, a plus kd. Now, we are going to required result. The given statement is true for n equals to k plus 1. So, here adding both sides LHS and RHS by equation 2, a plus kd. Therefore, a plus d plus a plus 2d plus so on plus a plus k minus 1 into d plus a plus kd equals to, here RHS means k by 2, 2a plus k minus 1 into d plus a plus kd. Now, taking the LCM means k into 2a plus k minus 1 into d plus 2 into a plus kd by 2. Now, multiplying this, 2ak plus k square d. Now, multiplying this, will get here will get 2ak plus k square d plus plus kd here multiplying this, 2ak plus k square d minus kd plus 2a plus 2kd by 2, that is here 2ak plus k square d, 2kd minus kd means plus kd plus 2a by 2, that is here in between two terms kd into k into k square d, kd into here k plus 1 in between two terms, and in these two terms plus 2a into k plus 1 by 2. Next of all, here k plus 1, again k plus 1 into 2a plus kd by 2. Next of all, write k plus 1 by 2 into 2a plus kd. This is the required result by the principle of mathematical induction. Prove that the given statement is true for n equals to k plus 1. So, in this statement, here in place of k plus 1. Here we'll get k plus 1 by 2, 2a plus k plus 1. Plus 1 minus 1 gets cancels, therefore kd. Therefore k plus 1 by 2 into 2a plus kd. We'll get the answer. The given statement is true for n equals to k plus 1. Finally, by the principle of therefore s of k plus 1 is true. S of k plus 1 is true. Finally, the given statement is true for by the principle of finite mathematical induction for all given values small n belongs to capital N, that is a plus t, a plus 2d plus so on plus n terms equals to n by 2 into 2a plus n minus 1 into d. Okay, thank you.